We are covering section 5.4 today, medians and altitudes. The objective for this section is to use median and altitudes in constructions. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So in this picture here, to illustrate that point, A is the vertex, E is the midpoint of the opposite side. I connect the vertex to the midpoint of the opposite side. That red line that I highlighted is the median. Now there's three medians in a triangle, one from each vertex to the opposite side. The medians of triangle ABC are BF, CD, and AE. The three medians of a triangle create a point of concurrency called the centroid inside a triangle. This point O is a centroid. It's where the three medians meet. So medians make the centroid. Point O is the centroid, as I said, and the centroid is the center of gravity of a triangle. So if I cut this triangle out and put my finger on O and balance that triangle, if I had my finger on O, the triangle would balance on my finger. Center of gravity. Coordinate example. The vertices of triangle RST are given. Find the coordinates of the centroid C. Okay, so to do this, we would have to sketch RST, and then we would find the midpoint M of RS. So we'd use the midpoint formula to find the midpoint of RS, and then we would sketch the median TM. So there's the work for the midpoint formula. Remember, you're averaging the x values and averaging the y values of the 2 points you're finding the midpoint of. So we take 1 plus 3 divided by 2 and 4 plus 8 divided by 2. We get the midpoint is 2, 6. Now we sketch the median. From T to M, it's the blue line. All right, any questions there? Okay, so then we find we do the median for each side. So the median for ST, the midpoint of ST would be 4, 4, and we would connect that point to the vertex, and then we would observe where the blue lines cross. They cross at 3 over 4 up. That's your centroid. Everybody have it? Raise your hand if you're not ready to go on. Okay. It says, notice the distance from the vertices to the midpoints of the opposite sides. The concurrency of medians of a triangle theorem says the medians of a triangle intersect at a point. It is 2/3 the distance from each vertex to the midpoint of their opposite side. So that's saying that AP is 2/3 of, we should have, let's see, they didn't have the points. So AP is 2/3 of the distance of A. This would be E right here. Right? So it's 2/3 of the distance. So if the distance from A to E was 3, then AP would be 2, and what would be left would be 1. It has a 2-to-1 ratio. This length to this is a 2-to-1 ratio, or if you think of it as a fraction, if this is 2-to-1, then that's 2/3. The whole thing is 3, and this is 2. It's 2/3 of the way across. So remember, that's the one that goes from the vertex to the middle, from the middle to the centroid. From the centroid to the midpoint is 1/3 of that whole distance. So we have our ratio there. The same for all the segments. This is 2-to-1, and so on. All right, so let's apply this. Q is the centroid. SQ is 8. What would QW be? If SQ is 8, and it's 2/3 of the entire distance across, what would QW be? Jacob?
4.
Yeah, it'd be 4. 2-to-1 ratio. This is twice of that. So it's, yes, QW equals 4. Well, what about SW? What would SW be? Eric, what would SW be? Yeah, it's 12. 8 plus 4. Questions? All right, here's an example. There are 3 paths through a triangular part. Each path is from the midpoint of one edge to the opposite corner. The paths meet at point P. SC is 2,100 feet. Find PS and PC. All right, so if this line from here to here, SC is 2,100, what would PC be? Apply our rule here. The same rule. PC is this distance. It's the longer of the two distances. So what would it be? Okay, PC, we know that PC equals 2/3 of SC, right? So we just plug in. PC equals 2/3 of 2,100. What is 2/3 of 2,100?
14.
Yeah, it's 1,400. PC equals 1,400. And if PC is 1,400, PS equals what? PS would equal to 2100 minus PC, right? Minus 1400. So PS equals 700. Questions? All right. Altitude. An altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. In this case, so we have an acute triangle. This is the vertex. This is the perpendicular segment to the opposite side. It's not the midpoint of the opposite side or anything like that. It's just the perpendicular distance. That's the altitude. In an obtuse triangle, some of the points will have their altitude will be outside of the triangle. For example, the original triangle is the QPR. If I try to drop the altitude from this vertex, it's not going to go inside of the triangle. It's going to be outside the triangle. So we extend this line PR so that it intersects. That tells you the height of the triangle. Like if you were calculating an area, you would use that as the height. Now, not all the altitudes in this triangle are outside of the triangle. If I did the altitude from P to the side QR, then that would be inside the triangle. It would be here. Right. All right, any questions? Okay. P is the orthocenter. Lines containing the altitudes of a triangle are concurrent. So they also meet in the same place. The point at which the line containing the three altitudes of the triangle intersect is called the orthocenter. P is the orthocenter. It's where the altitudes meet. Different cases for the orthocenter. In an acute triangle, the orthocenter is inside the triangle. You can see the three altitudes. In this acute triangle, they would meet at point P inside the triangle. In a right triangle, the orthocenter is on the triangle. In a right triangle, the orthocenter is on the triangle. It's actually at the vertex where the right angle is. And then in an obtuse triangle, the orthocenter would be outside the triangle. So your original triangle, the red lines are your altitudes, I'll do the. Let me highlight the original triangle. The original triangle is this triangle. That's your original. Oh, that's your original triangle. I went a little bit too far over here. Yeah, that's the original triangle. And the red lines are your altitudes. They're outside the triangle. All right, any questions? Everybody have those drawn? Okay, moving on. So let's recap. The construction of three altitudes makes the orthocenter. The construction of three medians makes the centroid. The construction of three, what makes the incenter? Which construction makes the incenter? It's on today's quiz. Angle bisectors make the incenter. All right. And the circumcenter would be made by what? Okay, it's made by perpendicular bisectors. I have a saying that we can use to help you remember which constructions make which point of concurrency. Everybody get those points? Okay. So we're going to do these constructions here in a minute. First we will